We are live. Hello, everybody. Boy, yesterday that was a brutal Zoom second period, huh? When we lost power. But here we are. We're going to try it again, okay? So today's lesson is actually 2.2 in Algebra 2. So before we do anything, let's go back to what a function is, okay? So what is a function? It's where every x value has only one y value, okay? Give me an example. So we talked about this last year too, about the lattes. If I go to the latte stand, and this is the number of lattes, 1, 2, and then the price, like maybe $2 and $4, right? I can order a latte. I really can. I can order a latte, and it can be one price only, right? One latte cannot have two different prices. That's impossible. So if I had a dot here and a dot here, that is not a function, because one latte can't have two different prices. One shirt in the grocery store can't have two different prices. One loaf of bread can't have two different prices, okay? It just doesn't make any sense. So if this point here is there, then you have one x value with two y values. That's not possible, okay? So now if we take a look at this line right here is truly a function. One of the ways, or easy ways to test, and I don't know if you guys remember this from last year, was the vertical line test. So if I were to take a vertical line, and if I could draw my vertical line straight down, if it hits the graph in more than one point, it's not a function. So this is called the vertical line test, okay? If that point were there, it's not a function. So if I take a look at the first example, yep, it passes the vertical line test. There is no place where a single x value has more than one y value, okay? So this is a function. So it's a function, instead of saying, say, y equals, say 2/3 x plus 4, if it is a function, we use this symbol, f of x. F of x and y are going to be interchangeable for now. When you see f of x, it means y, okay? Whoops, sorry. When you see f of x, it means y. So we can just say f of x equals 2/3 x plus 4. X axis represents all the x's, okay? Okay, number two, the second example, that is also a function because it passes the vertical line test. It doesn't pass what we call a horizontal line test, but it is definitely a function. Yes, it is a function. Nowhere here is a single x value have two different y values. Just single y value, okay? Okay, the third graph, yes, even though it's just points, it passes the vertical line test. Every single x value has only one y value, only one y value, one y value, one y value, one y value. So I'd say yes, this is a function, okay? The fourth example is a no. Right here, this x value has two different y values. It can't happen. This is not a function, okay? All right, now, the last example sure looks like maybe there's two y values here for this point, but since it's an open circle, it doesn't count. It has a y value here of 0, not this y value. So this is yes, because it's an open circle, it does not count. Closed circle, that's where the y value is. So yes, that is a function. Okay? Hopefully, oh, sorry about that. There you go. Yes, because the open circle, no. I got to keep an eye on this so I don't do that again. Okay? Slip that over. Okay? Now, let's go back to hopefully something that we saw yesterday. Okay? These are my parent functions, okay? This is y equals, or f of x equals absolute value of x. This is our parabola. This is f of x equals x squared. This is our parent function, y equals x. This is our parent function. This is an exponential. We didn't talk about this much. Whoops, sorry. This is our exponential. We didn't talk about this much, but this would be f of x equals some number. Probably we'll say 2 to the x power. Okay, these are my parent functions. Okay, and on the back side of our journal, we also see some other parent functions. We're not going to really talk about these yet. We'll talk about these later on in the course, but this is x cubed. This is a square root graph. We're going to talk about these later, not in this lesson. This is a 1 over x graph. And this is the opposite of this one, a cube root, okay? But we will not deal with this today. But there they are. Okay, now what are we going to deal with today? Okay, well, let's take a look at translations, okay? So today's lesson is translations. It is going to be 9/1/2020, okay? Translations. So, first of all, I'm going to use two different colors so you guys can see the original, and you can also see the translated function, okay? So here we go. I have my original function, f of x. This is square root of x. So hopefully we learned yesterday it's the v, up 1 over 1, up 1 over 1, up 1 over 1. Same thing here, up 1 over 1. Okay, here's my absolute value. That's my parent function. This says take our graph, f of x, and move it to the left 3 and down 2. Okay, one more time. One more time. Inside means opposite. So on the inside, so instead of going plus 3, you really go to the left or back 3. Okay, we go back 3. Last year I did the dance. You guys can't really see me do the dance today, but we'll talk about that maybe in a Zoom meeting. So I'm going to take this graph, go back 3 to the left, 1, 2, 3, and then down 1, 2. And now my parent function just gets translated back 3, down 2, and here is my new graph. Okay. Sometimes, because it's a new graph, we can call it g of x. So g of x would equal absolute value of x plus 3 minus 2. Okay. All right, number 2, fx equals x. Well, that's a straight line. That's linear. So I'm going to graph that first, right? It's kind of like y equals a 1 over 1 x. Whoops, 1 over 1 x plus 0. We don't normally write it like that, but y equals x looks like this. It's our parent function, up 1 over 1, down 1, back 1, down 1, back 1. Okay, there's our parent function. This is take it back. Oh, I said that wrong. Take it to the right, always the opposite, to the right 1, and then up 5. Well, it takes it anywhere. So if I go, I'll take the origin. I'll go to the right 1 and up 1, 2, 3, 4, 5. There it is. Pretty simple. Okay, x squared. Hopefully you guys know that's a parabola. 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. 1, 2, 3, 4. 3 squared, 3 times 3 is 9. It's up there somewhere. Negative 1 squared is positive 1. Negative 2 squared is negative 2 times negative 2 is positive 4. Negative 3 squared is a positive 9. Right, the parabola, just scurrying numbers. We did this yesterday. And there it is. Okay. Now, what am I going to do? I'm going to take my parent function. I'm going to make it twice as tall. And I'm going to have it upside down for the negative. And then I'm going to bring it up 4. So I think what I'll do first is go ahead and put the vertex 1, 2, 3, 4 right there. Let me get my other color. So I'll take and move it up 1, 2, 3, 4. It's going to be upside down, right? But twice as tall. So instead of 1, 1, it's 1 twice as tall times 2. 2 squared is 4, right? 2 squared is 4. 1, 2, 3, 4. But twice as big. 4, 5, 6, 7, 8, right? 3 squared is 9, but 18, twice as big as you can't find it, right? So I know it's symmetrical. So I'll just put the other points like this, and I'll graph it. How's that? Okay. All right. Moving over. Okay. Oh, we do have the square root graph. Oh, I put that on there. Glad I covered that. Look at that. Okay. So the square root of graph, square root of graph looks like this. Okay. So first of all, no negatives. You can't do the square root of a negative number. No negatives. Negative x value. Okay, you can't take the square root of a negative number. Impossible. Okay, it won't happen. Just remember, you cannot take the square root of a negative number. So you start with 0. Square root of 0. What's the square root of 0? 0. Square root of 1. That's easy. So you go over 1. Square root of 1 is 1. Square root of 2 is kind of a decimal. Square root of 3 is like 1.73, right? Square root of 2 is about 1.4, yeah, maybe here. Square root of 3 is about 1.7, but I'm going to go square root of 4 because that's an easy number. Square root of 4 is 2, so 4, square root of 4 is 2. I don't need all these numbers in between. I'll go all the way to 9. The square root of 9 is 3, so I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. No negatives, so the square root graph looks like this, okay? And again, we saw that. We saw that in your journal, right? We saw the, here it is, square root of x. There it is. Okay, now let's take this function and we're going to make it negative. Negative x, which means all of the values that are negative become positive, so this is a reflection over the y-axis. Reflect over y-axis. Okay, so it goes like this. Square root of 1 is 1. 1, 2, 3, 4. 4, because square root of 4 is 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just 3. Looks like that. Okay. Alright. X cubed. The x cubed graph looks like this because 1 cubed, 1 times, okay, first of all, let's go 0. Okay, 0 cubed is 0, so I'm going to put a point at 0. Okay, 1 cubed is like 1 times 1 times 1. 1 cubed is 1. 2 cubed, though, is 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. So at 2, I go up 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm going to go off the paper. All right, ready? Negative 1. What's negative 1 cubed? Well, negative times a negative times a negative is a negative, so negative 1 cubed is negative 1. So negative 1, negative 1. Negative 2 cubed, let's see, a negative times a negative times a negative is a negative. 2 times 2 is 4 times 2 is 8. How about negative 8? So 2, negative 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. And there it is. All right. Now, what am I going to do with this function? Well, I'm going to take it and I'm going to move it to the right 3, and then I'm going to move it up 2, okay? So what I'm going to do is take this point right here. It's kind of where it bends. It's called an inflection point, okay? So I take my inflection point. That's where it bends. I'm going to go to the right 3, 1, 2, 3, and up 1, 2. And I'll graph in the translated function. Okay, there it goes. Something like that. Okay, and finally, cube root. Well, we saw that also in our journal. This is what our cube root looks like. Okay, and we'll take our cube root function and we'll move it to the left 2, remember opposite inside, and then down 5. So, how's the cube root function? Looks like this. Cube root of 0 is 0. Cube root of 1 is 1. Because what times what times what makes 1. Now I'm going to go all the way to the cube root of 8, unless you want to use a calculator. But the cube root of 8 is 2, because 2 times 2 times 2 is 8. So it's got to be cube root of 8. 1, 2, 3, 4, 5, 6, 7, 8 is 2. It's very similar to this one, isn't it? Except for it's on its side. Cube root of negative 1. Well, believe it or not, you can do this. Cube root of negative 1 is negative 1 times negative 1 times negative 1 is negative 1. And the cube root of negative 8, let's see, negative 2 times negative 2 times negative 2 makes a negative 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, negative 8, and negative 2. Okay, so here is my parent function. You can also put these in a calculator or on Desmos and see them. All of those things will work. We'll get into Desmos later, okay? So then finally, what am I going to do? Well, I'm going to take and I'm going to make a translation. So I'm going to take things, in this case, remember, opposite of the inside. Opposite. If it's inside, it's opposite. So we're going to go to the left 2 and then down 5. So taking its inflection point, that's where it bends. We're going to go to the left 2. We're going to go back 1, 2, and then down 1, 2, 3, 4, 5. And it's going to look something, not perfect, bend like that, okay? All right, so your assignment. Let's take a look at your book, okay? All right, here's what we're going to do for our assignment for today, and I'll put it up on your assignment calendar. But I'm going to have you do 1 through 9. Do 1 through 9, and we'll do 10 and 11 as the extras. So we're going to go to page 32. The assignment is page 32. Hold on. Page 32. 1 through 9, and the extra, if you want the A, is 10 and 11. Okay, give me an email if you're totally confused. Text me. Whatever we got to do. All right, I'll see you tomorrow.